And we're starting the broadcast.
The broadcast is now starting. All attendees are in listen-only mode.
Welcome to the latest webinar sponsored by the new Workflow 4.0 e-newsletter and ClearEdge 3D. Our webinar topic today is Best Practice Structural Modeling with EdgeWise Structure, Case Studies of Faster, More Accurate Workflows. Hi, my name is Kevin Corbley, and I'll be your moderator today. I'm the Editor-in-Chief of Workflow 4.0, the newsletter of 3D scanning, modeling, documentation, ideas, and opinions. First, let me start by thanking you, our attendees, for joining us today. We know our topic's of great interest because this is one of our biggest turnouts for a webinar so far. We've got more than 400 people registered to hear about best practices in structural modeling, and we know you'll be pleased with what you learn in the next hour. And let's take a quick look at today's agenda. We have two professionals from the scanning and modeling industry who will be telling us about their recent structural modeling projects. First, Brian Elby will be telling us about modeling Commonwealth Stadium in Kentucky, as well as a long pipe rack project in Ohio. And then we'll hear from Keith McKinney reporting on a blast model created for a chemical plant. And then our own Kevin Williams will join us for a live demo of EdgeWise Structure. And as always, we'll wrap up by letting you in the audience send in your questions to our panel of experts. And let me run through a couple of quick housekeeping details. Everyone in the audience is muted, obviously except for the presenters. But feel free to ask questions via the question window during the session at any time. And what we're planning to do, though, is we'll take those Q&As at the end of the session. And you can send those in to us, and we'll direct them to the appropriate presenter. And the webinar is being recorded, and you'll get a link on that at the end of the webinar. And also, just a quick plug for Workflow 4.0. Don't forget to subscribe to the newsletter. It's the e-newsletter for learning, as well as sharing experiences, opinions, and best practices. And we'll have some quick introductions here. Let me introduce you to our panelists. First, as I mentioned, we've got Brian Elby. He's the HDS manager for TrueScan 3D, which is located in Ohio. And as you can see, Brian has over 17 years of surveying and scanning experience. And we also have Keith McKinney with us. He's the principal at PLC, and that stands for Piping Layout Consultants. And they are based in Louisville, Kentucky. And he's been doing 3D scanning and modeling for past 5 years, but has quite a lengthy lengthy experience in the industry beyond that. And then, of course, many of you already know Kevin Williams. He's the chief scientist for ClearEdge 3D, and he's going to be giving us a demo of EdgeWise Structure today. So, gentlemen, we're happy to have you with us. And let's take a quick look at the goals for today. We know you're going to learn a lot, and we always have some key takeaways. You're going to learn how TrueScan 3D and PLC are using new tools, including EdgeWise Structure, in their modeling projects. Brian and Keith will show you how they plan and execute collection of structural steel data in ways that leverage speed and accuracy. And they'll get specific in telling you how much time EdgeWise Structure saved them in their modeling workflows. And then, of course, we'll have Kevin Williams. He'll be giving that demo of EdgeWise Structure and show you how it can streamline your scanning and modeling projects. All right, and we like to say context is king around here. And let's set the stage for today's webinar by giving you that context. And I think it's going to resonate with a lot of you. I think everyone knows that structural steel and concrete elements are difficult to model quickly and accurately due to their geometric complexity. But the structural features in the model are critical to the final deliverable. And existing software workflows are time-consuming, they're inaccurate, or both. And project margins and deadlines can be jeopardized by the manual tools for modeling structure natively in Revit, PDMS, AutoCAD, or other CAD packages. All right. Well, now we are ready to get started, and I'm going to go ahead and hand it over. I'm going to bring on Brian Elby, And Brian, I'm going to give you the controls to move forward here. And there you go, Brian.
Thank you, Kevin. Just a little bit about TrueScan 3D. It's actually the scanning division of the Kleinders Group, which is a civil engineering, surveying, and landscape architecture firm based out of Cincinnati, Ohio, but we also have offices in Columbus and Dayton, Ohio as well. TrueScan 3D has been the scanning group of the Kleinders Group since 2011 when we rebranded and kind of took it out underneath its own name. We're a national scanning and modeling service provider. I've been providing scanning and modeling services for a little bit over 6 years now, and first jumped into the scan-to-BIM services a little bit over 3 years ago, back when we really started to have good workflows for that. And though we do all kinds of different types of scans from caves and everything else, we really specialize, for the most part, with building documentation for the AEC industry. So the first project we're going to talk about, or case study we're going to talk about, is Commonwealth Stadium. As you can see on the picture to the left there, I highlighted the areas that we were most concerned with on the scanning of the north, the south, and the east sides of the existing structural steel for the steel fabricator. And in this circumstance, they were really concerned with what all the steel was doing in the areas where they were having to tie in. So if the steel was bowing at all, or you know, any kind of small inconveniences or anything that would cause them problems, they needed to know what it was doing exactly. So in this case, we had to deliver the point cloud in RCS format so they could use that within Autodesk products, and then we also had to deliver a Revit model and a CAD model as well. So, I went too far there. So some of the unique challenges with this, the number one thing was just developing the Revit model prior to EdgeWise structure availability. Basically what we had to do was go through and we would cut sections of each column and beam, take some measurements, go through a steel catalog that we had, find the one that most closely resembled those measurements, and basically fit those in and then take those and align them to the point cloud. One of the other things that we had to do as well was, once we were done with the model, we basically had to take the as-designed column lines and align that with the existing conditions model in order to enable them to align our model and the design model together in one. And finally, the most unique challenge, I think, with this particular project and with some of the other projects that we've worked with as well is all we had to work with were out-of-the-box Revit families, and a lot of the steel members on this stadium were old and outdated, and they weren't in the current Revit family. So we had to actually go through and adjust our Revit families and create new beams, new columns, and everything else within our families so that we had the correct beams that were in there, because we had the existing drawings for this, and we were basically cutting through, and we would make sure that our measurements matched what were there, and then as long as it did, we would basically take those members and fit them into place. And with the existing out-of-box Revit families, a lot of those didn't exist. As far as the field collection workflow, we had to establish survey control on site, even though they already had existing control from when the original survey was done. A lot of that stuff had been torn out, and there was just no way to tie into the existing control that was there. So we ran surveying control, both horizontal and vertical, around the exterior of the stadium, and then through the interior concourses on the lower level and upper level using Trimble robotic total stations. And then we utilized Leica HDS 7000 and Leica P20 scanners and collected roughly around 140 scans. The project took a total of around 4 days on site. That included running all of our control, you know, walking through the project and everything else that we had completed out there. So the old modeling workflow consisted of us bringing everything into Leica Cyclone, registering everything together, and then exporting those out to PTS files, and then converting those files over to RCS files in order to bring them into Revit. We adjusted the traverse using StarNet, brought the adjusted coordinates into Leica Cyclone, and then took our scans, which were independently registered together, and georeferenced those to the survey control that we had in there. Originally, the modeling was done by one person directly in Revit, like I stated before, and we were inserting beams and columns per the plan drawings as long as they were matching the measurements that we took. As we got into this, though, we noticed that there were steel beams where they originally weren't supposed to have steel beams, and then there were beams that they showed on the plans that weren't there at all either. So in the end, the final deliverable, which is shown below, consisted of all the beams, columns, rakers, and existing members that were in there that they basically had to tie into. Like I said, many of the beams and columns were obsolete, not in the Revit library, so we had gone through and basically added those to our library so that we could have the correct beams in there per the sizes. So with the new modeling workflow, what we did was we went back once we got our hands on EdgeWise structure, and we wanted to see what kind of time savings we could do. And we basically did this on 2 separate projects. And with this one being a recent project, we figured it would be a good one to test out. So we basically took all of our stuff, brought it in, and converted the file format so that we could bring them into structure, and then began to start modeling some of the portions of the project. And we basically modeled about 40 to 50% of the project in order to get a good idea of where we thought we would see the time savings. It was all done by one person and then exported to Revit 2014. And basically what you're looking at below there is just one of the QA/QC tools. The 2 screen captures there below is once you click on a beam and you start going through the QA and QC, it not only shows you how that beam fits, but you can go through and change some of the parameters. So if that beam size was a little bit bigger than what it really appears to be in the cross section, you can change that right there in the QA and QC tools, which definitely saves a lot of time. So when we went back and kind of projected out with the new workflow based off of the old workflow, the old stuff took us around 155 hours to model all the beams and columns and rakers and everything that were in there. And the new workflow, I had spent about 40 hours or so on the part that I had modeled up. So we had kind of projected that out and figured that it would take us around 90 hours to model the remainder of that, and then get everything into Revit and get anything cleaned up that we might need to clean, which would have ended up in about a 42% savings by using EdgeWise structure over the old workflow. The second case study we're going to look at here is one that was featured in Workflow 4.0 recently. This was an older project that we had, and it was something that at the time, again, EdgeWise structure wasn't available. We did have EdgeWise MEP, and we used it on that. But the pipe rack was around 1/3 of a mile long, and again, we had to deliver the point cloud in RCS format as well as develop a Revit model for them. Some of the unique challenges with this project, again, just having to develop everything without EdgeWise structure, doing everything manually, cutting the cross sections, and this time we did not have the benefit of having existing condition plans. There were no plans at all, and that's why they decided to scan this particular rack. There were limited areas of access, so as you can imagine, in some places this pipe rack, in fact the image that's below is where it goes over railroad tracks, so it was pretty high up in the air. There were some catwalks along there to be able to get some scans in there, but we were very limited as to where we could take scans. And there were also 2 site coordinate systems, and at the time when we first started scanning, they weren't sure which one we needed to tie into, so we had to find points from both and locate those, and it got to be a little bit of a pain. And some of the other areas of access as well just had to deal with this particular site being close to the river. Some of the tanks that were around in the surrounding areas were actually regulated by the government, and in order to get into those certain areas, you have to have certain credentials. And luckily, our guys have what are called TWIC cards, which are Transportation Worker Identification Credentials, and it enabled our guys to be able to go into those areas without having somebody with us all the time. And the access to the site was very limited due to the fact that this pipe rack actually services about 3 or 4 different plants. So every day they were there, they had to check in with every single plant, and they were only allowed to be on site from about 8 o'clock in the morning until about 5 p.m. because if they stayed any later than that, they would have to check in with the next shift, and it just got to be where we were spending too much time going back and forth. So with the field collection workflow, again, we established our own site survey control and then tied into the existing coordinate systems using Trimble Robotic Total Station. Utilized just the HTS 7000 on this project, and it was only around 60 scans that we took. But the project took about 3 days just due to the amount of time that we had to spend getting on and off the site and then running our control and doing some of the other things that we had to deal with on the site. So again, the modeling workflow, very similar to the previous one. We adjusted the traverse and StarNet. Scans were done with Leica Cyclone, and then again we exported the coordinates, got them out onto the correct coordinate system, and then georeferenced the scans to that, and then exported them out for use in Revit. Again, with this one I said we used EdgeWise MEP for a lot of the piping, which definitely saved us a lot of time on that end. I know many people are probably familiar with that. But when it came to the structure, we had to do everything manually again. And with this particular one, there wasn't a tremendous amount of beams and columns. I mean, you can see on the final deliverable there, that's the entire model. There were a fair amount of them, but there were a lot of cross braces and different things that we had to deal with, and those got to become quite a pain trying to use traditional Revit, because when we tried to copy things that we had grouped together, it just wasn't working well for us, and we had to redraw some of the things, and it just wasn't a good workflow that we had going at the time. And I don't think it necessarily had to do with the way we were doing things as much as it was just trying to work directly in Revit. Again, no existing plans, so we had to use the structural catalog again. And then the coordinate system coordination was quite difficult as well, just trying to figure out which coordinate system that they wanted on, and when they finally decided, trying to get it on there and then get everything managed and ready in time. So with the old workflow, I actually went back and revisited some numbers, and what I found was the old workflow for just the structure alone took one guy around 128 hours. And again, with this one, I think we modeled more than half of it. And the amount that we extrapolated out, again, we had figured that it would take around 60 hours with the new EdgeWise structure, which would have prevented around 53% savings, again, which is much better. This one we actually did after we had done the stadium, so our savings got a little bit better. I think it was just from getting used to the software and developing a better workflow than we had originally using when we first started on the stadium. Some of the observations that I noticed with using EdgeWise structure is just the extraction of the steel. You know, you window around it and it fits it to the cloud for you. There's no need to you know, manually put a beam in there and then cut different sections to make sure it aligns with the cloud and rotate it into place. And it just eliminated a lot of time that it ordinarily would have taken. The QA/QC tools were fantastic. Like I said, you can go through it. It shows you that nice cross-section and how the beam fits in with that cross-section. And if it appears to have fit maybe the wrong beam, or maybe you're not sure if it's the right one, you can easily and quickly change it, and it'll change the size of that right in the cross-section for you, so that you can see how that would work. The intersection tool, again, worked fairly well. It was a nice thing to not have to sit there and pull every single beam together. We could quickly grab two of them and it would intersect them for you. So again, that saved quite a bit of time for us as well over the traditional way we were pulling things together inside of Revit. And then just the overall speed of modeling, like I said, it's much, much faster just windowing around it, and it put it in there for us, and we didn't have to try and go through and search through a catalog for the measurements and find the right size. And if that wasn't the right size, you know, kind of go one or two each way to make sure that we had the right one. So overall, it saved us a tremendous amount of time.
Okay, great, Brian. Thanks for that. And let me ask you a quick question now that you've had some experience with EdgeWise structure. What other kinds of projects do you think you might use it in?
Well, with the fact that we deal with a lot of buildings, and in fact, like I said, last year we did 3 stadiums alone that were primarily looking for structural components. We would have definitely used it on all those. And a lot of the buildings that we do work in, as far as the sometimes they're demoed areas where you can see a lot of the structure, so we would definitely use it on all those. Basically, just about any type of building project where we have any kind of structure at all, we're definitely going to be using it on.
Okay. All right. That sounds great. Well, that's terrific, and we appreciate you talking about 2 different case studies. And now what I'm going to do is I'm going to hand the controls over to Keith McKinney. And Keith has got some projects of his own he's going to tell us about. Keith, take it away.
Thanks, Kevin. Piping Loud is based in Louisville, Kentucky, and founded for its piping fit-up. PLC today still executes a high percentage fit-up designs, from locating equipment in steel to piping. This is why we moved to laser scanning in order to tighten schedules without sacrificing quality. Staying with the new technology, PLC moved to CAD designs in the late 1980s. In 1996, PLC started using PACE software to design projects in 3D. I was a previous employee of PLC, and in 2003, I was offered the chance to purchase the business in 2004. Rick Link and I took over the ownership and have operated it since. Seeing the efficiency of 3D in 2005, PLC moved 100% to 3D design. PLC began contracting 3D scanning services at first, and then in 2009 began self-performing all of our 3D scanning. What I'm going to talk about today is a existing chemical facility, and our end goal was to provide a 3D solid model of the existing chemical plant in order to create a CFD model to understand cloud dispersions inside the existing facility. The first building we scanned consisted of 3 floors and about 28,800 square feet. This project required more scans due to the tight spaces and the fact that the building is over 100 years old. PLC's deliverable was a 3D solid model of all the objects 1 inch and larger. With the use of EdgeWise plant and structure, we were able to model piping and structural components fast, letting us focus on smaller objects in the building that were just as important. As you can see, our scan to model time was very tight. This is a panoramic photo taken from the scanner. From this, it's easy to see what we were up against as far as the sheer amount of objects to model. CFD stands for Computational Fluid Dynamics, and it's used to understand cloud movements inside an existing facility. A software called FLAX was used to simulate the cloud dispersion. Some of the requirements are to collect all ventilation ingress and regress points, potential leak points, and of course using the 3D model. Once we understood the cloud dispersion and types of fuel, we can do a couple things. One, simulate a blast cloud that could show how that would affect the building and its surrounding areas. And 2, and the most important thing, is to mitigate the issue by controls or additional ventilation. This is also used, we also use the model for any new designs for ventilation and construction drawings. We modeled thousands of feet of piping and 3 floors of steel, and as I mentioned, the building was old. The steel sizes, but with old steel sizes, but we were able to efficiently extract the steel with EdgeWise structure. The schedule was tight. We used EdgeWise plant throughout the entire project. We used structure midway through, which helped us keep the final delivery date. We wouldn't have met the date had we not been for adding structure to our modeling tools. As the schedule slipped, the budget did as well, but once we added structure, it kept us within our budget. We used a Faro Focus 3D laser scanner and a Trimble RTS 773 robotic total station. consisted of 436 scans, and we did that in 17 days in an existing operating facility. One of the challenges that we had, Brian mentioned that a little bit on some of his projects, is we had no survey control out there. The only thing we were given was some existing drawings, so we had to establish survey control before we were able to start the project, which slowed us down a few days with the total station side of it. But the scanning went pretty well. Some of the things that we were dealing with was expanded metal decking that wasn't tacked down, so the vibration was bad. So we had to be careful for where we were even able to put the scanner. We registered the scans in scene 5.1. We used EdgeWise plant and EdgeWise structure, like I stated earlier. We used 6 modelers, and some of the challenges were just the sheer number of pipe runs, over 20,000 pipe runs, and the amount of structural steel. We modeled the steel and the building you can see there in the lower photographed. It was 3 floors of the entire building. And of course the level of detail. So you're looking at everything 1 inch and above. So we needed to put the scanner up on an extended tripod quite a bit to get it up high enough to be able to see the small conduits and such up in higher points of the building. And it was an old building which had been retrofitted many times, so there was a lot of miscellaneous steel, etc. in there as well. And EdgeWise structure was able to pick that up very well. We estimated our old workflow would have taken us about 700 hours to do the structure on this. The new workflow, we spent 370 hours with a savings of 52.8%. Some of the key observations we learned from using structure was it's very easy to learn how to use. We were very happy with the EdgeWise plant module, and it was very easy to learn how to use, and the structure was the same. Had all the shapes that we needed to model, and the most important thing for us is it exports well to our design software. And the workflow is the fastest that we've encountered.
Okay, great, Keith. Hey, quick question for you. Have you had an opportunity to use the software in any other projects besides the chemical plant?
Yes, we have. We had an existing tower we're going to model, and it was going to take probably 2 weeks to do the structure on it, and we were able, similar to what Brian said, to do that a lot faster in EdgeWise structure because we were using it on this project here. We did it in 3 days. It was eight levels of a exposed structure. So it was very useful.
Okay, that's great to hear. Well, we are just about to move into the demo, and before we go to Kevin Williams, let me just remind the audience we actually already have several questions in, but feel free, if they come to mind, go ahead, type them into the question window, send them over to us, and we'll get to them in just about 15 minutes at the end of Kevin's demo. And for that, I am going to go ahead and turn everything over to Kevin Williams. And Kevin, take it away.
All right. Can you pass me control, please, Kevin?
All right. There you go. Okay, you've got it.
Awesome. Thank you very much, Kevin. Well, I'm really excited to talk to you guys today about EdgeWise structure. I think of all of our product and version releases we've had so far, I'm probably most excited about this one just because it solves such a big problem in the marketplace. Be honest, really didn't realize how acute the pain point was for modeling structural elements, particularly structural steel, until just maybe 4 or 5 months ago. Sometime in the December timeframe, we started talking to a number of our existing customers who were modeling structural steel using other tools, and just kind of getting a feel for what they were doing to create these structural models. So sat down with a number of them, looked over their shoulders as they modeled the steel, and they're using all of the different tools out there, but surprisingly, most of them reverted to just eyeballing picking a structural steel element and eyeballing it into place. And it just seemed like such a long and tedious process. So I took this information back to my development team and challenged them to come up with a better way to do this. And I've been really quite proud of my team here. We've got some really great guys that rose to the challenge and put together what I think is a fantastic set of tools for modeling steel quickly and accurately, straight from the point cloud. So with that, let me kind of give you a quick overview of what the software does. It extracts properly specified steel based on a catalog of data, a catalog of components. The software ships with AISC as well as a handful of other specs from around the world, and we're working to fill out our catalogs, working with a number of our beta testers from different parts of the world to incorporate as many catalogs as possible, but you can also create your own catalogs very quickly and easily. The software exports directly to Revit. It comes in as intelligent Revit structural components and family objects. We anticipate having an export to PDMS very shortly. The software, from all the feedback we've gotten, is much faster and more accurate than what people are currently using. And soon we will be able to work with concrete and wood. The next version coming out in a couple of weeks will have concrete and wood working as well. Currently it just works with steel cross sections. And I should say it's technically still in beta at this stage. The final release will be about two weeks from now. But people are already using on projects, as you've already heard. So without further ado, let me pull up EdgeWise structure here. All right, so this is a small chemical plant. It's scanned with Faro Focus 3D. Just a handful of scans here, but the more scans the better typically, as long as they're well registered. You can see we've got a number of structural steel elements here. I've got a hand railing comprised of angle iron. So let me show you the basic extraction tools. I'm going to extract. You basically just window out a little area of the angle iron with the angle iron tool, and you see the green element there. It just created a piece of angle iron. Walk through a couple of the other different shapes. We can extract C-channels, T's, hollow square tubes, angle iron round, and of course W sections or I-beams. I don't have any round tubing in this particular data set, but I've got a pipe, and so you can just kind of see what it would look like. If I zoom in here, you can see we've got a round piece of steel over where that pipe is. You see we've got a piece of W section here, so I'll use the W section tool to extract that guy. There's a little structure here. There's a cross beam and then another steel column over on this side. Let me just quickly extract those guys out. I'll show you the connection tools later with them. All right, so let me turn off the point cloud so you can see what we've got going here. I've just extracted, looks like 5 pieces of steel. Integral to the software is our whole smart sheet technology. We've borrowed that from the plant software that we developed over the last several years. And if we open up the Smart Sheet, you can see that every single item here corresponds to a row in the Smart Sheet. So if I click on one, you can quickly see that it highlights it in the table and gives you all the information associated with that object. So we can easily change the size of these guys. We've got the entire AISC catalog. I've been working off of the AISC catalog, but there are other catalogs we can choose from. So all of the different angle iron sizes are here. So we can quickly resize it using that. Now, I found that fairly hard to use when we first built it, because the sizes of these pieces of steel don't always necessarily correspond to the they don't have an intuitive link between the names and the actual physical dimensions. It's often in poundage and hard to know what your shape is going to look like without having an extensive background in structural engineering. So we've got a resize tool that allows you to, if you notice on the left-hand side, we've got a QC window that shows the points that we use to extract each object. So if I change the size of this guy to something ridiculous, and I don't know if I don't know what size this is, we've got a very quick and easy tool to go in and resize it. Just draw a rectangle around across the extents of your point cloud where the steel lies, and it will refit it. So if I turn the point cloud back on, you should see that it falls right on top of the point cloud. I believe one of these extracted poorly. So this guy, we can go through and use the resize tool to resize him very quickly. Nudge him back into place, and he should be good. So the last thing, once you've extracted the pieces of steel, we've also got some very quick and easy tools to go through and snap these pieces and make good geometric connections between them. So you can see that the three pieces of I-beam that I extracted earlier should all connect. And so let me turn off the point cloud and show you what that looks like. I'm going to snap it to the top of this beam here, and then snap this beam to the sides like that, and now we have a good connection. The last thing I want to show is exporting to Revit. So I'm just going to export. I'm going to overwrite an existing file, and I apologize. Something happened to my Revit session. I'll open up a new structure template. And then using our EdgeWise plugin for Revit, I'm going to open up the model I just created. And it gives me a little report for how many different elements were created. And here I've got 5 pieces of steel that were created. And here they are. So I can click on each of these, and it's got the correct dimensions and correct name and everything. And it's an official Revit family, and you can do whatever you would do with something that came completely out of the box from Revit. So that's the new software. And my marketing team wanted me to make you guys aware of the introductory pricing that we've got for the software. It's been out in beta for a little bit, and we're starting to sell it now. For the month of May, we've got a special on the software. You can buy a single seat for just EdgeWise structure for just under $3,000. The entire BIM suite, which includes MEP, building, and structure, can be purchased for less than $5,000. And then for our existing customers, there's an easy upgrade path to include EdgeWise structure. Tack it on to your existing license for just under $2,000. So that was the EdgeWise demo, and I'll pass it back to you, Kevin Corbley.
Okay. All right, Kevin Williams, thank you for that. I appreciate it. And I'm going to ask you to hang on, Kevin, because we're going to go to Q&A right now. And before I ask the first question, just let me remind the audience to go ahead, send us your questions in the question box. We've already got several, but we've got plenty of time left to answer your questions. So go ahead, shoot them to us right now. And for Brian and Keith, I'm going to ask you to turn your mics back on, and I'm going to start hitting you with these questions. And Kevin, it looks like the first one's for you. We actually had a couple people ask more or less the same question, and that was how far back does the Steel catalog go in terms of the age of features?
We're using the current AISC catalog, but we're going to be working actually with Brian Elby very shortly to pull in some of the more historical standards, because I recognize that there's a whole lot of old steel out there and the standards have changed over the years. The other component is it's really easy to build your own standard. So if you've got a piece of steel that doesn't fit with the standard that you're using, it's really easy to fill out your own standard and put that steel in, put in those dimensions.
Okay, great. And let's see, a couple of questions came addressed to both Brian and Keith. So Brian, I'll throw this one to you. I think you were the first person who talked about easy to use, and somebody was asking what is the learning curve to become proficient in EdgeWise, and I assume they're meaning EdgeWise structure here.
I mean, I was familiar with the EdgeWise platform to begin with, just from using the MEP features. So for me, it didn't take very long at all. Like I said, it was a matter of just maybe by the end of the first day, I think I was moving pretty well, just getting accustomed to doing certain things and how to work with some of the cut planes with one of my structural components and stuff. But I mean, even when we were first learning the EdgeWise MEP, it did not take very long. I mean, people that are familiar with 3D modeling are going to catch on pretty quickly.
Okay. All right, great. And Brian, here's another one for you. Someone asked about the Commonwealth Stadium project. You mentioned 4 days on site. How many people did you have on the crew, specifically on the field portion of it? And they said, did you use just one scanner?
No, we had 2 scanners on that project because we actually scanned that back in December, and it was quite cold out, and our 7000 didn't like the cold very much, so that's why we had both the scanners down there. Originally we had 2 guys on site, one to do the survey control, one to scan, and then the guy that was doing the survey control was going to help him out with some of the other stuff while he was there, but it ended up, since we had to have 2 scanners, they were both running scanners after he was done with the surveying control. So.
Okay. All right. Great. And Keith McKinney, here's one for you. Have you had a chance to use Recap Pro for registration, and under what circumstances would you use Recap?
That's a good question. We just got back from the scanning conference last week, and no, we haven't used Recap Pro yet. Very interested in using it for the cloud to cloud. I know Brian uses Cyclone, and it does target and cloud to cloud. Recap uses only cloud to cloud, so you don't have the ability to register with targets. But Scene, from what I've been told, is going to have cloud-to-cloud registration in the near future. The drawback would be the obvious: if you didn't get enough overlap in your scans, and or there weren't enough features in the scans to be able to do that. But no, we're looking at moving to either recap or using Scene to do cloud-to-cloud registration.
Okay. All right, great. And
Hey,
Kevin
hey,
Williams.
Kevin,
Yeah, go ahead.
could I jump in on that one too?
Sure, please.
We have used Recap Pro. It just depends on the type of project that we're working on, really. Back when we first tested out Recap Pro, we kind of ran it through and was like, how long is it going to take to do this registration? And we tested it out on a smaller project, probably that had about, I'd say around 45 scans or so. And I didn't see a significant time savings in doing the cloud-to-cloud in there over doing cloud-to-cloud in Cyclone. So that's on a smaller project. Now, I think on projects where you may have thousands of scans or hundreds of scans, you may see some time savings. But we've also had a couple of issues with when we go to export out the RCS files or anything like that, having some scaling issues where the dimensions don't quite fit what they actually should be. And I haven't gotten an answer back from Autodesk on what's causing that yet. So.
Okay, interesting. All right, great. Thanks for jumping in on that one. And Kevin Williams, how deformed can structural steel be and still facilitate fit to cloud?
Not terribly deformed. I mean, if you've really got a twisting I-beam, it's going to have some problems with that. What I've recommended to a couple of our beta testers who've been modeling pretty significantly deformed steel is that they model it in sections and then connect those sections together. So the export is one of the big limiting factors. Like Revit, we have not figured out how to export a twisted piece of steel or a bent piece of steel yet. So until we can figure out the export, it doesn't really do us much good to capture that type of deformation in steel.
Okay, and how well does it work when the steel has fireproofing on it?
Actually, really quite well. The software obviously is not going to be able to automatically figure out how thick the fireproofing is, but using the resizing tool in the 2D view, so it makes it a breeze to go through and create those pieces of steel. So what you do is you extract it like you would normally, and it's going to get it wrong. It's going to put it much bigger than what it should be because there's fireproofing on it. But then you can look immediately straight down the point cloud, which is one of the big advantages of this technology. Is even if you've got something that's angled at 45 degrees, you can instantly look straight down the point cloud, down the barrel of your beam, by capturing it and then looking straight down and then using our resize tool to go back and put in the proper size of steel. And so it's 30 seconds to go through and put in a piece of fireproof steel correctly.
Great, okay. And Keith McKinney, on the chemical plant project, how did you divide the workflow among 6 modelers?
We had a seat of EdgeWise plant and a seat of EdgeWise structure. So we divided well, at first we divided the piping in building 1 between 2 guys, so we had two folks working on that full time. And then when we got the structure, we moved 1 modeler to structure and 1 to plant.
Okay. All right, great. And let's see. Let me see if I can find one. Here's an interesting one, another one for Kevin. How does the EdgeWise structure software deal with open web steel joists?
It does not capture the whole thing as a joist, but the current version, like I said, is actually still in beta. We've got some additional tools that are actually being finalized right now. One of those tools is the ability to group steel elements together. So if you wanted to create a joist or truss by grouping a bunch of elements together, you could then copy and paste it and work with it as a single unit. But we don't have predefined joists just yet. I understand that's something that's readily available inside of Revit and most steel packages. And so we're working with people for the next version to be able to have some of those pre-built joists and trusses already available.
Okay. And Keith, what computer processing capability did you need to build or edit the final model?
Well, we've got a standard i7 computer in our office here that everyone has. It's got 32 megabytes of RAM. We've got a NVIDIA Quadro 4000 video card. So that might be a little bit of overkill from what we're seeing with our experiences with using large point cloud data sets. The EdgeWise plant and structure software work just fine on that platform. So it may be a little overkill. That might be a good question for Kevin, but for those specs, it works fine.
Okay, Kevin, do you want to chime in on that one?
All of the development on our software is done using basically Walmart laptops, recognizing that's kind of the minimum spec that most of our customers will have, and so it's designed to work on a fairly low power computer, but the more power you have, the better things will work for you. But you don't have to. It's not a requirement.
Okay. All right. Interesting. And Brian, let me ask you this one. I'll read the whole question to you. What's the confidence in the final model? Steel sizes may be used for analysis and structural design. Is this recommended? Brian, you want to turn your mic on?
Yep, sorry about that.
That's all right.
You know, I think whenever you're dealing with steel, the one thing you're going to have to remember is if you're going to do any kind of analysis, even though there was a scan done, because even if you're using EdgeWise or if you're doing it manually inside of Revit, you know, and not doing the modeling on your own, you're probably going to want to go out and do some kind of verification with some type of caliper or something on some of those members to make sure that what's in there and what's depicted in the model is correct. Because whenever you're dealing with any kind of software that's extracting steel based off of the point cloud, it's doing a best fit with that cloud, the best that it can do. And, you know, there's going to be cases where it's probably right, but there's going to be cases where it could be wrong as well. So, I mean, my advice would be is if you're doing any kind of structural analysis or something like that on the members where you have to know exactly the size that's there, but you also need to know where the stuff is accurately, you're going to have to use a combination of the scans and, you know, some field measurements that are verifying that. And typically when our guys are out on site, I mean, they don't measure every single one of them, but they do measure quite a few of the columns, particularly ones that they notice that are different sized, so that we can use those during our analysis as well inside when we're modeling. So.
Okay. Yeah, and Keith, do you want to add anything on that, or is that Kevin wants to jump in?
I'll let Keith. I'd like to chime in on that one as well after Keith.
Okay. No, I agree with everything Brian said there. No, it does a good job of fitting it, but you know, you've got situations in the field where you've got steel that's distorted, or sometimes the software may think it's one thing and not exactly what it is. So yeah, if you're going to do analysis, you need to probably do some field checking.
Okay.
Yeah, I just wanted to put an exclamation point on that, because we've seen far too many. Scanning itself is really not accurate enough to get the thickness of a lot of these steel members. So you really got to be careful. You know, if there's misregistration of 1/8 of an inch, which is hard to achieve, to be honest. We rarely see data that's that precisely controlled. But even with just an 1/8 of an inch deviation, that can make a significant difference in the thickness of a flange, and so that's you know, and that can dramatically increase or decrease the calculated results from a structural analysis. So I think it's critically important not to actually go out and field verify if you're doing actual structural analysis.
Okay, and does it address tapered steel, Kevin?
Currently, no, it does not. They are straight extruded cross sections only currently.
Okay, and somebody wants to know what happens if there's something like a circular staircase. Can that be extracted, or do you have to do that manually in Revit?
I'll take this one. The different components can be extracted, but any circular pieces like the side rails and everything of the staircase are probably by definition curved, and so the software is not going to be able to extract that except in small segments. Anything that's straight can be extracted. If it's bending, the current version of the software will not extract that.
Okay, and Kevin, somebody asked if they know the size of the structural element or feature, can they use that to constrain the initial fit?
Absolutely. The version that I just showed, the beta version, does not have that feature in it, but the one that the team is working on right now does have that ability. And so and we've got a very intuitive interface to set that. So if you extract one element and you've got 50 more just like it, you can set it, you can lock that size and extract all the rest of them to be the same size. So it makes it really easy, and that obviously improves the accuracy of the results as well.
Okay, and it looks like we have time for just a one or two more questions, so I urge the audience to go ahead. If you have any last questions, send them in to us now. Here's an interesting one, Kevin, again for you. Well, the question's kind of odd. What about using a more accurate scanner like Surphaser? I'm not sure. The cleaner your data, Surphaser produces beautiful results. And the cleaner your data, the more accurate you're going to be on extracting sections of steel. If you do your registration really well, I would probably I was going to say that you might even be able to be confident in the extracted steel sizes for structural analysis, but I'm not going to say that on on a live webinar. I would still double check it in the field, but it's going, the cleaner your data, the better the results are going to be. Okay, fair enough. And one last question, and Kevin, this one is for you. Have you done any concrete extraction? Only in the lab. It has not gone out to any beta testers yet. Seems like it's going to work well, but we have one more really quick internal round with the beta testers to make sure that the concrete it's pretty straightforward. Honestly, it uses the very same technology. It's really just a question of refining how it fits into Revit, but it looks really good. That and wood. Okay, sounds like, go ahead, I'm sorry. I saw one other question in the chat box here about Revit 2013. We're compatible with 2014 as well, and soon we'll be with 2015. Okay, terrific. Well, you just got the last word, Kevin Williams, because we are out of time, and I want to thank, of course, Brian Elby and Keith McKinney for joining us today, and on behalf of our panelists and our sponsors, Workflow 4.0 and ClearEdge 3D, let me thank you and the audience for joining us today. And a reminder, you'll be receiving an email after the broadcast with a link to the recording, as well as a chance to subscribe to the newsletter, and there'll be some other follow-up information as well. And we hope to see you again for our next webinar. Thanks for joining us.